Hello everyone, and welcome to the 39th episode of Tech Life Skills with Tanmay. Thank you very much for joining in today. My name is Tanmay Bakshi, and before we begin, first of all, I do want to say I hope everybody had a very Merry Christmas. I hope you had a very fun time. As a matter of fact, yesterday was actually my dad's birthday, and so I would like to join everyone in wishing him a very happy birthday. You know, we baked a cake at home. It was a lot of fun, and we had a good time together. Now, I started this Tech Life Skills series back in March of this year. And my goal through the series has always been to take the stories of people who are doing really incredible things with technology and make them accessible to an audience, right? Give them that platform to share those stories. And as part of this mission, I absolutely love to hear from students on the show. And the reason is because I want to see what they believe the future of technology looks like, because they actually have a hand in building that future. I want to see what their role is in that too. And so that's why I think it is such a fitting end for the last episode of Tech Life Skills for this year to be a student special episode. And now I want to close the year by really hearing from the next generation of technologists who really are going to be defining the field in the years to come. And today we're being joined by two really amazing students that I'm incredibly excited to speak to. They are Soumya and Malikeh. Now they both have incredibly impressive resumes already as students. And so instead of playing a game of telephone and having me sort of reiterate that, I'd love to hear it from them directly. And so without any further ado, I'd now love to welcome Soumya and Malikeh to the show. Hi Soumya, hi Malikeh, how are you?
Hey, how are you?
I'm doing very well.
Hi, Tanmay.
Thank you for both for agreeing to be on the show today. It's really exciting to get to speak with you. And so now, before we begin, I'm sure everyone would love to know a little bit more about the work that you do and how you got here. And so I'd love to start off with some introductions. So Soumya, would you like to maybe start off quickly introducing yourselves, telling everyone a little bit more about you?
Absolutely. So, hello everyone. My name is Soumya. First of all, I'm super excited to be here. Thanks, Tanmay, for reaching out. Um, so, I am a final year computer engineering student at Ryerson University. Previously, I've done an internship at Scotiabank as a software developer intern, and I've held leadership positions at RU Hacks, which is Ryerson's official hackathon, as well as IEEE Computer Science Ryerson chapter. Um, and now I just secured a full-time role at IBM as an associate developer, and I've been working on a capstone project around computer vision, all of which I would love to dive in as we talk today.
Wonderful, great to hear. It's some really exciting technology to work with, so I can't wait to hear more about it. But of course, I'd love to know more about the work that you do too, Malikeh. So would you like to quickly introduce yourself?
Great. Hi, everyone. I'm Malikeh. A very Merry Christmas and happy birthday to Tanmay's dad.
Thank you.
Yeah, to talk about my journey in tech, I have to say that I think it is about, let's say, 6 or 5 years that I'm working specifically on computer science and computer engineering. Now I am MSc student at University of Toronto. My concentration is data science, and it is years that I'm working on the machine learning field and different projects, its applications, in different fields from health, wireless communications, and so on. I will talk about the details later. And I'm really excited to be with you all. And I'll be happy if you ask your questions and ask me to share my experiences with you. And also, I'm pretty sure that I will learn a lot today.
Thank you very much, Malika. Thank you, Sami. Great to have you on the show. And I mean, precisely as you said, Malika, everybody joining the live stream, make sure you send in your questions through the chat. I will make sure that we get to the questions that you'd like us to answer. But without any further ado, I'd love to, dive into this technology that you work with. I mean, I've heard a little bit about the projects that you two have worked on, and they really fascinate me. But of course, this journey, I think it's interesting to start off at the very beginning and sort of work our way up to what you're doing today. And so how about we start off with something a little bit simpler? I want to know how the two of you got into technology in the first place and what sort of inspired you to do so. So maybe we start off with you, Soumya, for this one. What exactly inspired you to get into technology? Why did you decide to take that up in the first place?
So that's a really interesting question. Like it really makes me think back to like all the people that like I thought I was starting out for, right? So initially it was like looking at the founders of like Google and like Apple and like Steve Jobs and all these people, and I was like, oh my God, this is what I want to do. And that was like the initial like motivation. And I was like, hey, like it would be so cool like working with all these cool technologies and meeting cool people like along the way, because that's what happens as a byproduct when you work with cool technology.
Mhm.
Um, and yeah, and then so I was really motivated by that. But then on the side I started taking this CS50 course from Harvard University.
Mhm.
It was this online course, and that's when I really found out like how unique the course, or like the field of computer science is, because it's all about like problem solving and thinking and like using your analytical skills, which is why I'm still here today.
Wow, that's great to hear. I mean, the fact that you sort of started off inspired by these, sort of, I guess, these really famous people in technology who have really, worked with technology to solve so many of our problems and make our lives so much better, right? Using technology for that, and seeing how you got into this course, and we're like, wow, computer science really is unique, right? It is really different. I feel like that's something that I can relate to a lot because, when I initially started working with technology, while I did start off a little bit differently, I had started off working with it just because I found it fun to play with. Back when I
Mhm.
was like five-ish is when I initially started like just playing around with technology, right? And that curiosity was just, the computer I can interact with in infinitely more ways than pretty much any other toy. But that sort of
Mhm.
evolved into, I started to see just how unique computers are. The fact that you can solve so many problems with them, the fact that you can get them to do, whatever it is that you program them to do, and that just continued to fascinate me more. So yeah, that's definitely interesting to hear, and we'll get deeper into that. But of course, you too, Malika, I'd love to see how did you get into the world of technology?
Yeah, sure. That's an interesting question to answer. I think I'll have to talk about a milestone in my life. I think I was in the first year of high school that I joined a robotic club of our high school, but at the same time, I decided to study for computer and mathematics Olympiads. I cannot say how much Olympiad affected my life. I think it was about 3 years that I studied for it, and it was a revolution in my mindset. Uh, I remember 2 or 3 days I was just focused on a specific question. Even understanding the problem I remember took me hours and hours. And yeah, it challenged my mind, and my passion toward mathematics motivated me to apply for engineering area. I think that was the main reason behind it. And also the role model of my life, who is unfortunately passed away. I think it was in high school that I understood an Iranian woman named Maryam Mirzakhani for the first time has won the Fields Medal.
Mm-hmm.
And yeah, I read about her, and she really inspired me in my life. It was my dream to see her someday from close, but because of breast cancer, she passed away. But I always try to be like her. I always try to set my goals just the same as her. And yeah, it was the milestone in my life. And after that, at the end of the day, I decided to apply for computer science because it was intersection of so many things that I could do, kind of mathematics, algorithms, all of the things that can satisfy my mind, because I have always looked for something challenging to solve a problem, detect a problem, model it, and reach to the point that can help the others to make their lives easier and easier.
Mm-hmm. I mean, it's so inspiring to hear, how you have this mindset of it really comes from all sorts of areas, right? Like, for example, how you said computer science really is that intersection of so many different things that you find fascinating, right? Like, so all the way from mathematics to, problem solving and the computational thinking that goes into figuring out, what is it that I should be programming in the first place, right? I feel like whenever we talk about programming, especially with people who are sort of new to the field, a lot of
Yeah.
the emphasis goes to the actual like act of writing code, whereas that really is just a portion of what you actually do as a computer scientist or someone who programs and works with computers. Really, the vast majority, I would say, of the time that I spend even coding isn't just writing code, it's thinking, what is it that I need to code in the first place? What is that logic that I want to implement? And that problem solving and sort of where that intersects with mathematics and all these other fields definitely is really fascinating to sort of cover.
Yeah.
Now, of course, you did mention before that you are interested and you sort of specialize and you focus in, for example, data science technology. Now, the reason that fascinates me is because, as I'm sure pretty much everyone knows, machine learning technology is sort of that one thing that really fascinates me, right? Back when I was like, 11, even when technology started to like bore me, machine learning is what really excited me because I was like, oh, we can do so much more with this than we could before, right? Like looking at Watson playing Jeopardy, for example, was just incredibly fascinating to me. And so I wanted to work more with machine learning. And as I've sort of worked with it for the past couple of years, I've noticed there are lots of questions that people have about machine learning. I mean, I personally think that generally, outside of technology, machine learning and AI are some of the most misunderstood technologies in the world by far, maybe. And so I want to ask you one of those questions that I get asked a lot, and that is machine learning and data science. What exactly is the difference between them to you? How would you define those terms? What do those technologies let you do? Yeah, would you like to sort of share your thoughts on that?
Sure, I will go for that. Actually, as you know, my concentration now is data science, and it is years that I'm working on both these fields. And some people kind of have misunderstanding about their difference. There is a delicate border between them, and at first, I will talk about data science and then I will go through machine learning. Whenever I want to talk about my field to a person who is not technical and has no idea what computer science is, I always say data scientists are a lot like cooks. Yeah, it is the procedure of coming up with a super delicious food. Starts with buying fresh and high quality ingredients. At first, a data scientist is really, really relied on the high qualified data, and then you gather it. And that's the first point. These two are so much alike. Then you wash the stuff and now you sanitize it because of COVID. That's exactly the same as a data cleaning. And the data scientists start with data collection, data cleaning, data visualization, you explore it, and afterward, in the middle of the way, you will see machine learning. It's kind of like the recipe that you have to go through, and based on that, you have to kind of mix the ingredients and go on with whatever you want to do. And I always say the testing of the food, adding salt, adding whatever, is kind of testing the algorithm through the way you test it with the validation set over and over, and you optimize it, manipulate the parameters, and at the end, you will come up with a super delicious food, which is your model. Yeah, it's non-technical to talk about data science, and I can say data science is the intersection of machine learning, programming, and mathematics. If you're not interested in math, you cannot get rid of it in data science and also in machine learning. But I can say the balance between statistics and machine learning is really important with in data science. And the procedure of data science is kind of more complicated than machine learning. I think I can talk about machine learning as a subset of data science. And to tell the truth to you, just knowing the algorithm, just knowing what you are doing, just to choose an algorithm will not do whatever you want. As I said, if you do not have good ingredients, if you do not have good data from scratch, not to know what are the ways to deal with the data, you will not be able to use machine learning. That's why I decided to apply for data science as my concentration, to have a more deep and kind of comprehensive insight about this area. Yeah, I think that's my inference about their difference.
That is such a unique analogy. I've never heard that analogy to a data scientist being, a chef. And the reason that I love it is because it makes so much sense now that I think about it, right? Because maybe even more of an analogy to a data scientist being a chef, you could say, I mean, as you mentioned, chefs have to rely on having those fresh, high quality ingredients to begin with. But then also, a part of the sort of role of being a chef is being able to say, all right, I have this to work with. What can I make that's good out of what I have, right? Even if they're not the highest quality ingredients, how can I work around that? How can I, cook them in a certain way or use certain machine learning algorithms, right? To get the most out of what I do have access to, right? So I feel like that analogy does make a lot of sense. And then especially what you mentioned around, the recipes, for example, I guess the people who come up with the recipes, right? So the machine learning engineers, the people who actually work on the core machine learning algorithms, I guess you could relate them to like food scientists, the people who aren't necessarily the chefs and aren't there, actually doing the cooking, but the folks that are out there, understanding the chemistry of how all the cooking actually happens and coming up with the recipes and stuff. So, there's definitely an intersection where some of that work sort of overlaps a bit. But there is that distinction, right? And I think that's something that's really interesting to explore. Now, there is also, Soumya, is there anything else you wanted to add to that, or should we move on to a question from the live stream?
Yeah, just like a quick addition, I think the way I view data science is kind of like also a mechanic. Like, given a car, like the it's not necessarily that you're like starting from scratch. You're also like given something and you just have to find a way around it, right? Like if you think about a mechanic fixing a car, they just know that, for example, the oil's leaking and they have to think of ways to like resolve that. And that's been my application, my work with data science. So that's how I see it. But I also like really love like the chef view because I've never like heard that perspective.
Yeah, no, they're
Thank
definitely really interesting ways to phrase it. Yep. Okay, so now there are a couple questions from the live stream that I want to get to before we continue. There are a couple things that I want to know more as well. But I want to start off with a question from Tassin. So Tassin's asking, what would be the first and most basic class or course for a high school student that you would suggest for someone that wants to explore the world of technology and is considering a career in it? And so, any resources that you believe would be helpful?
So I believe that like learning about computer science and all of that is a lot of self-learning. But on top of that, to like supplement it from school, the way I did it was like my school offered computer science classes in grade 10, 11, and 12, and I took them all 3 years. And then there's also this optional like computer engineering course that you could take. So if you're interested to, with hardware or like if you have questions about it, and like if you're unsure if that's the realm you want to go into, like that's definitely a course you can take. I don't know how it play out in like a COVID scenario, but I
Hmm.
still think the class is valuable, and if you can take it, like definitely take it in grade 11 and 12. That's how I did it, and it really like offered like um a vast and then like more comprehensive view to me about like technology. Like it wasn't just like, oh, you just write code, but you also like implement it with like technology. So
Right. So it is definitely valuable to take those classes, but also, Malike,
mhm.
what do you suggest?
you. Actually, I wanted to add something. It depends on what you're looking for.
Hmm.
First of all, for anyone who is going to come into technology, I will not talk about the other areas. Specifically, I'm talking about computer science. For sure, in order to communicate with your laptop to command it and it obeys, you have to, first of all, learn a programming language. It is really important. Start with easier ones like if I were at that age, I would start with Python. I started with C because I was working with robots and so on, but I would recommend you to start with Python for so many reasons. Because in different platforms it's used in machine learning, in web development, even if you're gonna work with things like Raspberry Pi or the other stuff, it has so many use cases, and it enables you to, you know, it gives you a way to communicate with your computer.
Hmm.
And also, I think it is not really kind of obligatory to start very soon with super intensive projects. You have plenty of time, and I think it's really not bad to gain some technical and non-technical skills from scratch and give yourself time. You can start with projects, but I think it is really important, specifically in high school, that you have plenty of time, and sometimes you're not so much under pressure to seeking for a job. Seeking a job. And in that case, I would recommend you to work a lot on your mindset. Before getting into technology, you have to be a good problem solver. And in order to do that, there are so many resources online. You can learn coding in less than a week. I guarantee you, it's really easy to write down hello world and go ahead, copy paste so many resources. But the main factor to be different and outstanding is to be a good problem solver, problem detector, problem solver, a person who is good at modeling things and adding something to this world. That is what I really recommend you. And I don't know, math, physics, they're all, someday you may find them irrelevant to the area you're working on. You say, oh my God, why they were teaching such uh, silly stuff to me at school. But the thing that they give to you is the computational mindset, computational thinking. Work on it. Give this time to yourself. Read books, read about the bio of people, how they reached to the point they are, not how Steve Jobs programmed the things, how Steve Jobs detected the problem, how Steve Jobs went through the procedure. That is the point that makes you different from the others.
Absolutely. I absolutely love that mindset, the computational thinking, the computational problem solving. And, precisely what you mentioned, things like, math or physics, they might seem unrelated at first, but they really can not just put you in that mindset, but even sort of intersect with technology in a way that you might not realize because, technology isn't really its own thing anymore because of how pervasive it is. It's really infrastructure for every other field to work with. And when you're applying technology in any field, you need to know about the field you're applying it in. And just a quick example, what I found pretty fun. A little while ago, I was working on a project that required me to work a lot with modulating and demodulating data from really high frequency audio, from 44 kilohertz and above. And that required a lot of effort because I mean, as you can imagine, I had to rewrite entire audio filters and the fast Fourier transform from scratch in C to get it to run on a very specific system setup. And I worked on that project, went well. Couple years, actually a year later, couple days ago, in fact. After I'd worked on that project, a friend of mine, I was on a call with him, and for some reason his keyboard's not connecting to his Windows computer, but it will connect to his Mac. So what I suggest is, why not put together a little Python program on your Mac that takes your keystrokes and, modulates it to ultrasonic audio, and your Windows computer picks it up and simulates those keystrokes. And it worked. And this project actually then ended up being useful for so many other things, right? I mean, the fact that technology is so generic and the fact that you can do so much with it really just means, if you have that sort of computational thinking mindset, that problem solving mindset, you can then take knowledge from what might seem like completely unrelated fields, right? Like math, Fourier transforms and things, and apply it to things that you think would be completely unrelated, like how can we transmit the data from my Mac to my Windows computer to get it to work as if my my keyboard was connected to my Windows computer, right? So it's really all about that mindset, I think, at the end of the day. So I love that point. Now, there are actually quite a few more questions that we are getting from the live stream chat. There is one that I want to ask from Nihar. Nihar is asking, and this one's a little bit more technical, and I will get to some other questions as well. But I want to hear your thoughts on this before I sort of give my thoughts as well. And this is, why do we have so many programming languages? Yes, it is interesting, but what value does it add? So I have a whole sort of compiler end of things to say here, but what are your thoughts on that question? Do either of you want to sort of talk about that? I'm not sure if that's sort of like your area of expertise, but
I will go for that.
Sure.
Since the first term of my undergrad, each term we had to learn a new language. Based on the course, we started with C, C++, Java, MATLAB, or Python. I did all of them in my bachelor's. And I will tell you something. First of all, sometimes you see these programming languages are kind of doing the same thing at first glance. But people, at first, I can say that people with different tastes and different mindsets are using these programming languages. And if you're going to become a computer scientist, first of all, you have to choose the programming language which matches your mind, which matches your way of thinking, best of all. For example, if you work with Java is really, really matched with object-oriented programming. It's really helps you to look at everything in the world as an object, as classes, and it's really structured, but it's super complicated in comparison to something like Python. For example, Python is my favorite language. It's really handy. It's easy to use. The syntax is, I think, really, really near and close to the language you speak. I think I would recommend it to people who are not going to learn a lot about the language itself, but they are always looking for something to implement what algorithm which is in their mind. For example, if you learn C is it's in comparison to the other languages, it is more low level. It is close to machine language. It is hard to work with. There are not so many libraries that you do not even have vector there. It is a headache to work with it. But for example, if you're gonna work with Linux, you want to manipulate it, do something related to operating systems, for sure, it is the thing that is helpful. If you're going to work with, for example, work on robotics, C++ is helpful. First of all, you have to see what you are looking for. And for sure, each of these languages have specific libraries. For example, R is really good for data science. You see so many libraries over there to visualize the data, to analyze it, specifically the things which are related to statistics. You see so much of them in R. For example, MATLAB is super powerful with mathematical analysis. It depends on what you are looking for. At first, you see, oh my God, what people are doing, tons of different languages. What's the reason behind it? For sure, people from different backgrounds, different mindsets are working on these languages, and you have to give this time to find your appropriate language to feel free to work with. For example, maybe I cannot learn Chinese. It's really hard for me to pronounce it, or maybe it's hard for me to learn. Some people feel they are okay with French. Some people are okay with English. It depends on your taste. Yeah, I think that's one of the reasons behind it.
That makes a lot of sense.
I think adding to Malikeh's point, like on top of the applications, it's also like after the applications aspect, like once people know like this language is for this and so on, then they pick a language that they feel most comfortable with and that they would spend a lot of time like coding and developing and like building side projects on, which is where the taste aspect comes in.
Exactly.
Yeah, you're right. Taste is definitely a huge element of it. And I feel like that's, obviously the reason that people have like a favorite programming language, right? Like for me, for example, that would be Swift. Another reason, just really quickly before we get to the sort of questions from the live stream again, one more thing that I will say really quickly is also that, with human natural languages, a lot of the reason that we have different languages is because of culture and the fact that in the past, human societies have sort of developed individually and not as like a single cohesive unit like we do now with the internet, right? And because of that, fundamentally, if there's a collection of people in a city in China and India and Europe, somewhere in Europe, then they're all going to develop their own languages because it has to be specific to their environment and how it is that they think. But then with programming languages, there definitely is that element of taste, right, when it comes to the pure syntax. But there's also the element of how is the language engineered specifically to talk to the computer, right? Because, like, for example, if you're coding in Go, even if maybe you don't particularly like the syntax, as a lot of people don't, maybe you'll still code in it because it lets you access Go routines, which are, threads that are mapped to the Go level instead of the user space or the kernel space, right? And maybe if you're coding in Swift, it's because you want to code iOS applications, and you can use automatic reference counting, which is built into the compiler as a more efficient version of memory handling for you, right? If you're coding in Rust, maybe you're doing systems, but you don't want to manually manage memory, right? There's all these different reasons, even at a low level, that you might want to choose how to code. So lots of different languages are important, and we will also cover that more on the next episode of Tech Life Skills. I'll tell you what that's about towards the end of today's show. But regardless, thank you very much, Malikeh and Soumya, for your thoughts on that. Now, though, I would love to also answer a question from Sahil Agrawal. So he's asking, and this one's an interesting question. Does a degree really matter in the sense of, do companies demand data science degrees to get jobs? So this is a question that I think is a lot more open-ended and a lot more case-specific than I think we can sort of just generally say. But still, though, what are your thoughts? Are they helpful? What can you do? Any thoughts for Sahil?
So I'll go first. I think there are like two schools of thoughts. There's the old-fashioned way where you do need a degree, and that's kind of like an outdated point of view, but it's still like the most common view, right? And then the second one is you don't need a degree, but then you work on side projects, and that's how you show yourself that you are competent in that field. And going to the first school of thought, looking back, I think definitely a degree, like a lot of the skills that it teaches you, you may not think that it really like translates into the real world, but like the soft skills and sort of like the problem solving and like that mindset that we talked about that you're building like throughout your degree really helps you in many facets of your life that you can't even imagine.
Mm-hmm.
And so I really value and believe in that mindset. And then there's the second um viewpoint with the no degree, uh and like totally agree with that too, because I've seen like people who do like boot camps and like then work on like so many side projects, and like they have just as much experience as us with like degrees, and maybe even more, just because they are so specialized, which is great. And I think you should definitely like sit down and like write down your own like pros and cons of considering each option, and like what that would like do for you, because sometimes like the financial aspect may be a problem,
Mm-hmm.
or just like access to resources may be a problem. So that's what I would suggest.
Mm-hmm. Definitely, as I mentioned, kind of case specific, right? It depends on
Mhm.
your experiences, what it is that you want to learn, your financial situation, what sort of jobs you're looking at, what companies do you want to do your own thing. It can have a lot of different variables that factor into that decision. But Malika, your thoughts as well.
Yeah, I agree with Soumya. I think if I were an employer, I would not ask for the degree because of some reasons. Because I think it's a choice that should be made by a person, and it only depends on your personalities and characteristics. For example, I think we have, as Soumya said in another way, I think we have two types of people. Some people are really good at self-study. They are really self-oriented. They know how to schedule their time. They know how to select relevant resources, manage their time, manage their mind. They will learn it. They are not relied on an instructor or an educational system. But I decided to go to university, not to gain a degree, because I think if you give this chance to yourself, first of all, uh, there are some people who are likely to have more experience than you. And because of their experience, they know what are the things that can be useful. Maybe if you do it yourself, you will waste a lot of time just to know what the correct path is. Sometimes they just uh, you know, they just prepare it and give it to you, and they tell you, okay, go ahead, that's the path. That's kind of difference. Maybe that's a way to save your time in some way, but sometimes because of the, in my undergrad, I had to pass so many courses which were really irrelevant to my field of interest. I was just overwhelmed. Oh my God. From VHDL, VLSI, logical circuits to AI operating system. I know my laptop now better than itself. And I think it's really not needed. Sometimes your time is really limited and you want to focus on your field of interest. It really depends on what you are looking for. But if you feel you're really good at self-study, that's your choice. You can do it. I think it does not matter a lot.
Right. Again, it as you mentioned, right? It is pretty much case specific, right? In some cases, people might want to do it because you might want to get that degree because you want that sort of stamp, you want that certification, you want to be able to sort of say that I've done this, and you can sort of have that sort of voucher of I know X subject or X topic. And I mean, as mentioned in the YouTube live chat, there was a comment from BQ mentioning that degrees are important to round out the person because you may not need a degree just for sheerly learning to code, but you might sort of help. It might sort of help you express yourself. So, there are definitely lots of different viewpoints to it, and it depends on what it is that you want to do, what you're looking to be able to sort of work on in the future. But hopefully, Sahil, that was helpful for you. All right, now there is another question from Tassin because I feel like this is related to this question. That's why I'm going to take this up now. He has a question about would it be good advice for a homeschooled student to explore the field of technology more deeply and to work with it? Before I hand that off to the two of you, one thing I will mention is, I'm homeschooled as well. And, one thing that I will say is that regardless of whether you are regularly schooled or homeschooled, something that I think is important is there are those sort of core concepts that I think are really important and really integral to technology. I mean, Malika, you mentioned it before. Things like technology not necessarily require, but are pretty deeply interrelated with, the math and the physics and all these other concepts in other fields. And these are important concepts to be able to grasp and understand alongside getting into technology, regardless of whether or not you're homeschooled. But of course, any advice from the two of you on that one? I feel like we kind of did cover that a little bit, but anything else you'd like to add? Either one of you can start. Maybe we can go with Soumya first.
So I'll go first. I think when you are homeschooled, and I don't have personal experience, but this is just me like speaking from like an outside perspective, is when you are homeschooled, I'm pretty sure like you're like very like you have a flexible schedule, right? So you can like schedule like when you want to like take your break or like when you want to study. And in that case, like again, I think it comes down to the person. Like if you know that like, hey, like I can spend like 8 hours like doing schoolwork back to back and then I'll be done and then I'll take a quick break and then I'll spend some time, like let's say like 2 hours every day coding, and like that's a routine that you can stick to, then like kudos to you. And I think it like like when I look at all these like accomplished like developers or like accomplished engineers, like they're just motivated by like an internal passion for like learning and like problem solving and um, fixing the issue at hand. And they rarely have someone like telling them exactly what to do. And so what I would say is like definitely like if this is your passion, like don't let anything stop you. Like take that time, take that opportunity, and like especially when you're young and in high school, you have so much more time than you have like once you get into university or if you like start working. So yeah, that would be my advice and like my thoughts on it.
Right. I mean, I do agree. You do have definitely a lot more time, when you're homeschooled, when you're in that sort of, schooling period where you actually can devote a lot more of your free time to things like coding. I mean, generally, though, I will say that when you are passionate about something, you end up sort of inventing the time to work on it. Because, like, I mean, I've, there have been times where I'm, really incredibly busy, but just because programming is something fascinating enough to me, because it's just fun enough, I will find the time to be able to work on it. But yeah, no, Malike, what do you think?
I think I had kind of similar experience. in my high school because I was studying for math Olympiads. I was a lot away from a school, specifically in the third year of the school. I had only attended the final exams. I did not participated in the classes themselves. So there are so many critical points to have in mind, especially because I can say you are not mature enough in that age to schedule everything well, specifically if you're not having a great mentor at home who is experienced enough to tell you what to do, how to organize yourself. It is really important to know what you're gonna do. First of all, the first thing that you have to bear in mind is to master the communication skills and the things which are super related to society and yourself. Make sure you have them. Read books, try to expand your community over LinkedIn, Facebook. Try to kind of uh, make yourself skillful in them. I have one book that I would tell anyone in technology to read. It is the five dysfunctions of a team. I read it, yeah, weeks ago, and I think you will learn a lot about how to collaborate people around you. And after that, if you are going to go to technology, for sure, you have so much more than a person who is going to regular school for yourself. You have plenty of time to read about different things. If you are going to apply for engineering, technology, it is really important to be insightful about the world around you. For example, in machine learning, it has so many applications in health, in biology, in genetics, in many of this stuff. Some people are blind programmers, are blind computer scientists. These people cannot be good problem detectors. And if you're not a good problem detector, you will not innovate something new. You will not add something to the world and help the others. Computer scientists are the ones who have enough tool and technology in their hand. And if you empower yourself with general knowledge about the world, you will have a great insight to implement the things which can make revolution in the world. If you go through the, I think, biography of Jeffrey Hinton, he's the godfather of neural network. And if you see how his flow of life was like, you see he experienced everything from physiology, from psychology. He has knowledge in all of this area. I'm pretty sure that the reason behind his success and his path of education was his general knowledge. Specifically, if you are young, you have plenty of time to read a lot, read books, read online resources. We are provided with so many resources online, and we can master our minds to think in a different way.
I really can't agree with that more, right? Being able to have that sort of general knowledge, I personally can say is really, really important, and it can help you in so many unexpected ways, right? In ways that you don't realize until it eventually happens. All the way from, for example, when it comes to machine learning and sort of AI, natural language processing happens to be at sort of, one field that really interests me most. And, being able to just understand more generally, how languages have evolved and the sort of psychology behind how humans understand language and things like this can be helpful in even architecting simple neural networks to do simple text, classification or scoring tasks. And even just understanding and trying to explain how these systems work also it can be incredibly helpful for. And so, I really can't agree more. When it comes to technology, especially, being homeschooled, you have so much more of that flexibility and freedom to not just learn about technology, but also get so much of this general knowledge around it to be able to be really, really, good at not just working with technology, but looking for problems, finding out how you can apply all of that knowledge to solve it using technology as a tool. So I love your thoughts there. There is another interesting question from, let's see over here, it's from Mayank. And
Mhm.
he's asking, is Go worth learning? So one thing I will say is the Go language is personally really interesting to me. It's something that, I've taken a look into a couple times. You may have seen on the YouTube channel before. I've done live streams with my friend Omer using the Go language for a couple different things. As a matter of fact, the two of us are currently writing a book on the Go language, which is going to be my fourth book and the second book in the Tanmay Teacher series with McGraw-Hill. It's coming out spring 2021. So I'll put a link in the description of this video. Do check it out. You also asked, for example, project ideas. That book will give you a ton of different ideas of different things you can implement. We took, some ideas from blockchain and a couple other fields, put it in the book. So hopefully that'll be an interesting resource for you. But yes, Go is an interesting language. Of course, it does depend on what you want to do. I would say for things like back-end development and working with like containers and generally the back ends to large distributed systems, Go can be really helpful, especially because of like that highlight feature. Go routines and channels, those user space threads are incredible for certain tasks, and so do definitely check that out. But anything you want to add about the world of Go? Have either of you worked with Go before?
I don't have any experience working with Go. All I know about it is like from friends is that at Uber, like that's a very common language that's used. So like if that's where you want to work at, then like definitely go
Yeah.
right ahead.
Yep, I mean, Go is definitely an interesting language. Has a lot of, I will say, controversial choices that they've made. The thing that I like least about the language is the fact that symbol names, so things like functions and structures, the capitalization of the first letter in the name of the structure determines its access control. So if it's a capital letter, just that you start your
Mhm.
function or your structure with, it's public. If it's a lowercase letter, it's private. I don't see.
Oh.
I kind of get it, but you know, come on. Even Rust has a little bit of the classic elements of programming embedded. I mean, anyway. So that different discussion altogether. But Go is an interesting language and it can be used for a lot of different fun stuff. Also, another question from Hamad on the live stream asking, what's easier, Python or Swift? Um, I mean, of course, I would say Python's easier than Swift. From a raw ease of use standpoint, sure, Python can be easier. But what you should code in, I would say, depends on what it is that you're doing. There have been lots of times where I'll want to quickly put together a script. I want to figure out what the output of this specific mathematical function is when I run it for, x equals 1 to 512, and I'll just quickly pop up the Python repo in my terminal and type in like 3 lines, and I'll have the output that I need. But if I need to write something that takes, a gigabyte of JSON data and formats it in a certain way and finds, a certain element within the string, then maybe I would want to use Swift for a little bit better performance, right? So I think it really depends on what it is that you want to do because they're both easy. It's just that Python is much easier.
Mhm.
So, I think it kind of depends on what it is that you want to work on. Now, finally, a question for the two of you. So there's a question here from Anuj, and he's asking, I'm a beginner in AI and machine learning. So what basics should I learn in areas like statistics, algorithms, to start a career as a data scientist? Can you suggest resources? Now, you did mention data scientist. Of course, a part of that is machine learning, and there is a YouTube series that I have where I'm teaching machine learning and deep learning from scratch. So I'll link to that in the description. But apart from that, what do you think? What are some other resources that you think are helpful for learning, data science and the concepts that sort of go behind it on the internet?
I will go for that because um, I think some of the online resources really helped me through my educational path in this way. As for data science, as you mentioned, machine learning is part of it. So if you're gonna become a professional data scientist, first of all, read deeply about linear algebra, calculus, multi-variate calculations. They're all involved and prerequisite to understand the machine learning algorithms, and also some of them are directly used to have a sense of what is going on in data. I think on Coursera, there are so many online resources from Johns Hopkins University related to statistics and data science specialization. I found them really helpful. Most of them are based on R language, but the concepts are really useful. And I think that's a good start a starting point to begin with. And after that, I think, yeah. mm, First of all, I want to talk about the programming language. Don't confine yourself to learning languages. Okay, just spend 2, 3, or 3 days on it, and then go for the concepts. There are so many things to learn, specifically machine learning, and you cannot get rid of the mathematics used in it. If you go to the pattern recognition and machine learning book, you will not understand more than 2 chapters of it without mathematics. You cannot get rid of it. And if you do not understand what is going on in the algorithms, I think you will be lucky if you come up with good results. Some people come in, I think it was weeks ago, someone came and asked me a question in LinkedIn. He told me, I don't have a good mentor. I want to start with machine learning. Can you help me? What should I do? And I said, okay, sure. And he said, machine learning is super easy. And I said, is it the whole thing you're learning? I said, yeah, maybe. And he said, it is 3 lines of code to implement linear regression and predict everything. I came up with super fantastic results. It has good accuracy. What are you studying now? And I said, okay, you're so lucky that you came up with solution for all of the problems around the world. But first of all, if you do not know what is going on in the machine learning algorithms, sometimes you are likely to make wrong decisions. Some people use linear regression for all of the problems on the earth. But come on, some of the algorithms in machine learning are super related to the data points you are feeding them. For example, if you go and learn the machine learning algorithms, some of them just have good performance on the data points which are normally distributed. Yeah, you are lucky because most of the data sets collected from the world are likely to be normal, but in some cases it will not happen. And yeah, that's when the disaster happened. That is the thing that I'm studying. And for example, some people come and say me, oh, I came up with a super accurate algorithm, and it says my algorithm has 99% accuracy. I was pretty sure that a person who is a novice in this way is not likely to come up with that accuracy. For sure, if you do not know how to evaluate your algorithm, you cannot go forward in this way. When you have a data set which consists of 99% zeros, you do not even need machine learning. You can predict everything as zero. Okay, so you are not a machine learning engineer. You just I think first of all, you have to talk with yourself. If you are really like to develop web, you can copy paste the codes created by machine learning engineers into your program to add AI to it. Okay, in that way, you cannot call yourself machine learning engineer. You're a web developer who is using the outcome of the machine learning engineer in the program. And if you're going to become a machine learning engineer, sorry, you have to learn mathematics for sure in depth to understand any book in this area. And without knowing what is happening in the algorithms, you will not be able to even evaluate them correctly. It's really important to understand what imbalanced data sets are, what overfitting is, what is the difference between parameters used in linear regression itself. There are so many parameters that you can change, and slight changes in each of them will change your final results dramatically. I think all of them should be considered. Machine learning is not easy, believe me. It is it takes so much effort to understand each of the algorithms deeply. Yeah, talk with yourself and understand if you are a developer or you are going to become a machine learning engineer. That's a milestone in your life. And after you decided, I will talk about the rest.
I love what you said there, because so many people will use the output of like machine learning systems, and it's great that you can do that, right? The fact that we're making AI
Sure.
sort of democratized this way is amazing. The fact that you can
Mhm.
spin up an IBM Watson instance and you instantly have natural language classification at your fingertips, the fact that you can just load up a Cornell model by Apple and instantly classify or do style transfer in real time on your phone, that's amazing. But you haven't developed the actual machine learning algorithms, right? Those are developed by people that do understand the actual math and everything that goes
Mhm.
behind the machine learning to get that to work in your application, right? It's kind of like, just because you use Twilio to send a text message programmatically doesn't mean you're an expert in the whole networking that goes behind sending SMS messages, right? You use Twilio,
Mhm.
which is still great, and you can still make an impact by using it,
Yeah.
but you weren't the one actually that built the SMS network, right? There's this one really fun little image that sort of uh, uh, I guess sort of really represents the message that we're trying to get across here. I texted it to the two of you, and I'll show it on stream right now as well in a second. I'm going to take the two of you off screen for a moment. Um, but yeah, I think it pretty accurately describes exactly what we're talking about here. So, with with neural networks, what a lot of people will do that don't already have experience with the actual sort of math and understanding how to put together the actual architectures is, well, what if we just had a deeper network, right? That's the sort of famous thing that people will do with neural nets. And so, yep, that happens. But when you do get that experience, when you are able to understand what sort of goes behind it, then you really can do some amazing stuff. So yeah, hopefully that was helpful, Anuj. And again, we will be putting some links in the description to different resources that you can use to learn these concepts. All right, let's see here. There is another question. This one's interesting. Um, so this one's from Prognosticator on YouTube. They're asking, is it too late to start learning coding at 17 years old? I'm 17. No, it's not. but still, go ahead, Soumya Malikeh. What do you recommend for a 17-year-old to learn to program?
Um, I think, see, I like, see, like, obviously when it comes to programming, there are obviously people who have been coding since they were 5 or like since 10 years old. And yes, they'll have more experience than you, but you're never late. Um, and I think it's all about like the mindset and like, you really having a passion for it. I think like if you can teach yourself something, to be able to like, let's say like work on a simple app, like don't even start with anything complex. Like if you can build like a small like tic-tac-toe app, and you can get it working like from start to finish, that's already something that shows to you that you have passion, and like given a challenge you can like work your way around it. And especially when it comes to coding, like it's really about like, um definitely like understanding core concepts, but then applying it more than you like just read about it. Because uh like I don't think any programmer would recommend like just reading books and books and books and not like doing a project. Um and another point to that is like you can like never be wrong to it, right? Like let's just say you become a really good like web developer, and then after that you want to like go into machine learning. You can definitely make that switch and you're not like late to it. A lot of the concepts and the mindset that went into becoming this like proficient web developer will come in handy when you try and learn about machine learning, or AI or like data science or any of that. And um, yeah, and don't like be like disheartened by that, like, oh, I'm just limited to being a web developer. You can always pivot and like learn more. And yeah, and that's the whole field of computer science. Like it's like you're always learning, like there's always a new technology, so you can't know possibly everything. And it's yeah, it's all about like how much you can learn, like be a learn it all, not a know it all.
Completely agreed. Learn it all, not a know-it-all. That's definitely a highlight. But also, Malika, anything to add there?
Yeah, I think never is late. I think you can start whenever you want, but it is important to be motivated to stay on the track. I think there are so many resources that you can use to start with, like Solo Learn, Gigs for Gigs. I think W3 School. There are so many resources online that you can use, but learning the language itself is not important. It is really important to understand how to implement the codes. I think when I was new to programming, I used to attend some of the competitions on a hacker rank. Yeah, and also you can also, if you are interested in machine learning and data science, Kaggle is so much helpful.
Mm-hmm.
There's so many basic, even basic courses on the website that you can follow. You can start with Titanic dataset. I will recommend anyone who's going to work with Kaggle. It is a good starting point. Yeah, the competitions are have two positive points for you. First of all, they motivate you to optimize your code, get you better results, and give the correct answer. And also, when you face with a real world problem, and you implement the things you've already learned, that will be really helpful. Because sometimes when you go through the books or online resources related to programming language, they overwhelm you with so much detail. Not all of them are really needed. And if you go through real world project, you see you will not be required to memorize everything, see what are the syntax are like. You will face some error messages in your terminal. You can search it online. Stack Overflow is really helpful. You can debug it. Okay, so give the chance to yourself to implement, see the error, and gradually you will master the skills in yourself. And that's it. It's not late. Don't worry. It's okay.
Right. I mean, it's never too late. I remember that a couple years ago, Apple WWDC, there was in their intro video they highlighted developers of all ages, and there was one that was I believe in either her 80s or 90s, and still coding and writing applications, and it actually just learned how to code, and it really is never too late. It's also never too early, right? You can always start with something even as simple as Scratch or Swift Playgrounds, or something as complex later in life as like C or Java. It really doesn't matter. Again, what you'll be able to implement and sort of solve problems with, again, sort of comes down to not only the amount of technology that you know, but the related fields, like as you mentioned, the math and the physics or the science or whatever. But still, learning technology, I don't think it's ever too late or too early, especially at 17, right? I mean, you're still, I mean, compared to like average, you still would be relatively young getting into technology. So you're not at all are you too late to learn how to program. So thank you for sending in that question. All right, so let's see here. Another question. So we did also just take, well, there are two questions from Nishit. He's asking, how do we start learning machine learning? We just took this up. You can sort of rewind a little bit in the live stream. You'll hear us talk a lot about that. Really quickly, just to sort of summarize, there's my YouTube channel, there's that AI deep learning series that I do. There are resources like cognitiveclass.ai, as well as a couple others that Soumya Malikeh have mentioned that I will put in the description of the video as to learning, machine learning, data science, and also a lot of the concepts behind it. But I will also go ahead and take up another question from him, as well as another user on the chat called Cyberpunk. His name or his question is, what's the highest level of math required for machine learning? So we've already covered this a little bit, so we'll keep this a little brief. But either one of you, would you like to answer? What's the highest level of math that someone would need to learn to get into machine learning technology?
Actually, as for this question, I can tell you knowing the basics of linear algebra and calculus is enough. Don't get afraid. Just there are so many resources online that you can go through. I think the ones of which is on Coursera. I think it is. I'm not sure about the title of it, but it's data science, mathematics, statistics, something like that, which is boot camp something. I don't remember the name, but the series provided by John Hopkins on Coursera is really helpful. It depends on your taste. I don't know. There are so many resources online, but don't get afraid. Knowing linear algebra, knowing eigenvectors, just the stuff like that, which are the basics of the algorithms, is really helpful. It is not needed to finish 3 or 4 thick books in mathematics, then go through the machine learning algorithms. You can go through the algorithms and see what are the basic mathematics used in them. And if you see you do not know that, go and search about it, read about it, and then come back. You will understand it so much better. But do not skip the things that you cannot understand because of mathematics. Go read deeply about it, try to understand, infer whatever it's going to tell you, and empower yourself with basic mathematics. I think calculus and just linear algebra is enough. It depends on how complicated the stuff you're going to work on with.
Yeah, I totally agree, right? I mean, it does depend on how complex you want to go, right? Like, I mean, if you just wanted to do pretty simple, I want to build a little convolutional neural network to classify an image for this app I'm building. Like, if you want to be like coding centric with machine learning is something you do on the side, then, pretty basic stuff should suffice. Matter of fact, you could probably just copy stuff over from the cross documentation. But all of a sudden, if you want to, write handwriting synthesis algorithms that use mixture density networks with LSTM recurrent neural networks, then yeah, maybe you want to learn more about linear algebra and the calculus and how exactly the gradient descent works through the mixture density network and things like this. So that's something that you should look into. So hopefully that was helpful. Now, there is another interesting question. So first of all, Rishi Raj, I do see there's a question, what were some of the problems that I faced in my early days of learning how to code, back when I was like ages 5 or 6. I will take that up either later in the live stream today or on next week's show, which is an Ask Tanmay, where you'll get to ask me any questions that you have. So please do wait for just a moment. There are a couple of other questions that I do want to ask Soumya Malikeh first, though. There is a question from BQ, and he's asking the two of you, was there a mentor or a teacher early in your lives that sort of helped you select the path that you are taking today? And so, love to know. Either one of you can go first. Maybe Soumya, we can start with you.
Absolutely. So I think my family, like my immediate family, like none of them are developers or like even like remotely related to the field. So for me, like when it comes to like finding a mentor or any of that, for me, where it truly came from was through my internship, like the people who I met, and along the way, there were people who were like, "Hey, Soumya, like, I really appreciate like how enthusiastic you are about like developing, and like I'd love to like have a coffee chat and like guide you along the way." And like what you need to understand about mentorship is that it's like a two-way street, right? Like the mentor should want to be your mentor as much as you want them to be your mentor, right? Because because there are so many talented people, and but not everyone wants to be a mentor to you, and like, and by that same token, like you don't want everyone to be your mentor too. So really like understanding or like looking at areas of your life where people are reaching out to you and saying like, "Hey, like I'd love to help you get started, or like help you with this problem that you're having," then definitely like take up those people on those offers and see if you both like vibe and like vibe, if you both like get along and really like connect, then that's definitely the person for you, and definitely the person that you want to stay in contact with, because it's definitely a relationship that you want to maintain. So like definitely like keeping up with them, and not just like, it's not just like a transaction, like you just don't have that coffee chat and you're done. You definitely like keep in touch with them, and like and they want to keep in touch with you, like, right? So they'll reach out to you like, "Hey, like Soumya, like how's it going, like what's up?" And like you'll also reach out like, "Hey, like what's up?" And like you just like keep in contact, and in that way it's a very like organic relationship. I don't think you ever have to ask someone, like people or people who like see that in you should like reach out to you.
Right. Mentorship really is a two-way stream. That's definitely been a sort of highlight. On Tech Life Skills, we've done an episode with James Archieri, one of my mentors, and one of the sort of key elements that we talked about as sort of mentorship, which is one of the themes of the episode, was the fact that it really is that two-way stream, right? It's not just it's not just going one way. It really is both sort of mentoring each other in a way. So yeah, that definitely is really interesting to hear. Malika, what about you? Was there like a specific mentor that you had that sort of really guided or some of the decisions that you made in life regarding technology, or even outside of it?
Yeah, not to specifically mentor, but luckily through my life, I encountered super influential people, and I think each of them has a specific impact uh, on my decisions, and in order to stay on the track, keep motivated. As I told you, in the first year of my high school, I decided to study for math and computer Olympiads, and the reason behind my motivation toward this area was my Olympiad teacher. He's now in, I think, Sweden. He is working at Ericsson company, and he's an AI engineer right now. At that time, he was teaching geometry for math Olympiads, and he was the winner of gold medal. And I can say he was a super fantastic teacher, and he really motivated me, specifically when I was really hopeless. Because you will face two types of people in your path. Some people tell you you can't, you're not capable of doing this. You are perfectionist. You just see yourself something, but you're not a thing. Believe me, I have experienced these people too. And you are the person who have to empower yourself with the positive vibes and let the negative vibes away. Yeah, I have to say hello to him from here. Yeah, he was Meysam Ehghaghi, and he really helped me a lot. In that time, he really believed in me, and he changed my life completely. And also the principal of our school, she was Miss Harizadeh. She was the principal of Maryam Rizakhani, also in the past, the one I said, the winner of the Fields Medal. Yeah, and she has always encouraged me in my life. She believed in me, and she said, I see so much resemblance between your way of thinking and her, and I was like, wow, wow, and I was super excited from her compliment. Yeah, and they both helped me a lot not to get hopeless because of the negative vibes. I was surrounded with such negative vibes, but they helped me stay on the track. And also, I encountered with super fantastic teachers and professors at university. So many of them were really encouraging. But I think if you see someone who gives you positive points, who is living a life that you like, talk with them, ask for guidance, don't be shy. They can influence you in a way that you do not even believe that, oh my God, that is the influence that changed the direction of my life. Get close to the people whom you think they have similar frequency as you. I think that was the thing that I think inspired me through the path of my life.
I mean, I gotta say, there's a comment on the YouTube live stream that perfectly, sums up what you just said, from Rishika. A light of hope, that's what we need. So yeah, I totally agree with you, right? What you said is incredibly meaningful because, apart from, outside of even just technology generally, whatever it is that you're learning, first of all, being passionate about it is one thing, and that's something that we've definitely covered on the show before, but also, having that sort of being able to find that positivity and sort of being able to find people that do think on the same sort of frequency as you and sort of being able to work with them and get their advice can be incredibly helpful. So, I do definitely agree with you on that one. Thank you for sharing your thoughts. There are a couple more questions from the live stream, and I'll get to them in just a second. But first of all, though, Soumya, I do want to quickly ask you. I do know that you have had an internship at Scotiabank, and you've also now managed to find a full-time job in the middle of the pandemic. So I want to ask you really quickly, how'd you go about actually doing both of those, right? So we're getting a couple career-focused questions, and I want to know a little bit more about your actual career. How'd you go about getting that internship and now finally getting a full-time job?
Absolutely. So the way I started was like initially, even my first year was competing at hackathons. So I remember like the whole craze like back in 2016, 2017, even now I still see it, is um, that environment that you want to be in with like these like-minded smart people who are driven and want to build like a complete project end to end over the course of a weekend, and you sort of like get sucked into that culture, and at least that's what happened to me. And I started competing at hackathons, and then through that I realized like, hey, like this is definitely like something I like doing. And then along the way I met really cool people, and just I stayed in contact, like definitely like had coffee chats with them, stayed in touch, and that's how I was able to like land my internship, um and then like the full-time offer, it was a similar way. Like I think it was definitely just maintaining those contacts that I had met at those hackathons, or like through organizing um RU hacks and IEEE. Like it was through that, like the connections that I've built through that was how I was able to find that offer. And I think like my approach to like job hunting is that you should never like go like build connections just for the sake of like getting a job, because that rarely works. I think it's all about like maintaining relationships and maintaining um, connections, and like have an ongoing um, you know like um relationship with people, because that's how you really like get a job, or like get mentorship, or get um like just um get advice. And yeah, and definitely like don't apply online, that does not work. That would be my advice, is to definitely go out there. If you're interested in hackathons, definitely get involved, see who's coming, and build that rapport with them and stay in touch, because you never know who can help you.
That's absolutely right. I mean, I really feel like there's so many parallels to the networking episode that I held with James. So I will make sure I go ahead and put a link to that in the description. We talked about the empathy that goes behind building technology, and how to network, mentoring, all these different things. So I will go ahead and link that in the description as well. So yeah, thank you very much for those thoughts, Soumya. Before we continue, I do want to also ask. I know you're working on a really interesting project for your capstone, regarding computer vision technology. So tell us a little bit more about that. How does that work? What does it do?
Absolutely. So, okay, so in engineering in Canada, during your final year, you work on a capstone, which is a final project. It's broken down into 2 semesters. So your fall semester, you work on the research and learning more about how you would implement your solution. And then in your second semester, which is the winter semester, you actually implement the solution. And so currently my project is on computer vision using AI um, to detect yoga poses. And so the problem is that, as we know widely, that exercise is the solution and the cure to like all problems and stress and anxiety and all of that. And but the problem also is that performing poses correctly is really how you reap the benefits from them. And which is why we came up with this solution, because a lot of the times with yoga too, like you really need to um, do the right poses to really like benefit from them. So our approach was using is using PoseNet, which is a subset of computer vision, to detect yoga poses, and um, building a model to see how well you match up against like professional yoga instructors, and how close you are to their poses. And yeah, and that would be through an app that would tell you like how well you're doing, if you're like 50% accurate, like 60% close, or higher or lower. And then accordingly, like you would change your yoga pose. Um,
That is
Cool.
that's a really interesting application. I gotta say,
yeah.
I feel like this is actually precisely what we were talking about before. What sort of Malika mentioned. I'm sure that what goes behind your application is way more complex than just, hey, slap on PoseNet and take a look at someone's pose, obviously.
Mhm.
But the thing that I feel is so nice is that if someone wants to build an application like this today, you don't need to go find like a data set of human annotated poses and then build a neural network from scratch with no prior knowledge of what the
Mhm.
architecture needs to look like, and then start training it and do all your hyperparameter tuning, and then you don't need to do all of this. You can start off with a strong baseline thanks to this sort of open source community that's been fostered for this technology, and then you can work off of that and build so much more on top of it. Like for example, your algorithms that I'm sure you have for like comparing someone's actual pose to what the poses are expected of from professional instructors, and being able to do these things. So
Mhm.
I feel like that is so interesting that because of this amazing community that we have, it enables innovation to happen so much more quickly, and so much more meaningfully too. So that's definitely really interesting to hear. Speaking of which, actually, Malika, you too. What's like the favorite project of yours that you've worked on so far? Maybe the most complex, or something that you've just found really interesting to work on.
Yeah, as I mentioned before, from the, I think it was second year of my undergrad, I decided to attend different laboratories and kind of uh, internship positions to work on different applications of machine learning. In that way, I was going to help myself decide what branch of machine learning I'm mostly into. I have worked on different projects. As for my final project in undergrad, I was working on ECG signals to detect the arrhythmias from the dataset given by MIT BIH on the PhysioNet
Mm-hmm.
website. It was a fun project to work on. It was my first time working with clinical and medical data. I think it took me 2 or 1 month to read the books related to that, how to understand the arrhythmias from looking at the ECG signals and so on. I have never been into medical science, yeah, but because of this project, I did learn a lot. Um, and yeah, it was a combination of data science, convolutional neural networks, LSTM. It was super fun, and we were going to implement something to to do many things with the ECG signal. We had fed it with the activity level of the person who we are capturing the ECG signal from. Also, we were using kind of the pics, the QRS, detecting I'm not sure if anyone here know what ECG is, but yeah, you have so many complicated challenges to deal with in this area. Heart has so many arrhythmias, so many types of ECG problems, and detecting them is kind of hard. Not all data sets can cover them, and actually the people that you have to get this data set from are really hard to work with, specifically the ones who are coming from elder generation. They cannot tolerate hours and hours like this capturing the ECG signal from. Yeah, it was nice. It was kind of combination of computer vision problem with machine learning, but I cannot say it was the most interesting one. I think one of the most interesting projects I have already worked with was web scraping of golf statistic data set. It was one of the projects we had in our course, and I think at first we did not know even what golf is. I have never played it, and we tried to analyze what are the main factors involved in the success of the golfers at the end of the year. And there is a website named PGA giving you so many statistics of the different golfers, and analyzing them using time series, neural networks, PCA, and other algorithms, we were going to understand what are the statistics that if a golfer focus on are likely to win the champion or win the match or whatever. Um, and I want to mention something here for people who are new to this area. If you do not have enough background in the data you're working with, uh, mm, do not share your results with the others. first of all, acquire knowledge about the area. For example, we did not know what golf is, and at the end, we came up with the result that um, the driving distance is the main factor involved in the success of the golfer. And believe me, the driving distance is how strong a golfer is. For sure, a person who shoots a ball strongly is likely to win because he will get close to the hole rapidly. The reason behind our fault was because we did not have enough knowledge about golf. We were super confident about our results, but it was not valuable for a golfer or a statistician in this area. And I want to share with this. And after that, we decided to work on different statistics worked used in this area. I just want to mention this example to make you sure using machine learning blindly is not enough. Have an idea what is the data set you're working on. Talk with the people who are expert in this area, and after that, try to add something to the knowledge of people who are expert in that area. If you do not add something, it has no value for the people you're working for.
I absolutely agree. Right? Such a the reason that I love what you said there so much is because I've always said that machine learning experts really, really need to work very closely, and data scientists in general really need to work very closely with domain experts because they're the people that understand the data that the data scientists are working with in the first place, right? So, I mean, I feel like a great example might even just be Amazon, right? Like if you think about Amazon, they do way more than just looking at your purchases to recommend things to you. Not only are they looking at your purchases, they're even looking at the way you interact with the website, right? When you move your cursor around, when you type, they're using that to predict where your eyes are looking on screen, and then they're using that to predict what they should recommend to you. Like they're going really deep here, and without working with psychologists and experts in retail and experts in, all these different things, it would be impossible for them to create such advanced and intricate recommendation algorithms, right? So really, especially with data science, I feel like technology generally, but especially with data scientists, you have to work with the domain experts. I have seen time and time again there have been software tools even when we're not dealing with data scientists, where I will be working at a company, right, and I'll see like internally they built this huge software suite, they spent months working on it, they had lots of money, and then they'll go to a client and they'll be like, but this wasn't built for us. Like it doesn't make sense. Why would we want to use this? This is meant for experts. We're not experts, right? So, there's just I feel like it is really important to be able to work with the people that actually understand the data. So thank you for covering that. As a matter of fact, there's actually a question from Cecily now that I think is interesting, and I think we should cover this. We're getting close to the end of today's episode, so any more questions, feel free to put them in the channel, try and cover a few more. But Cecily's question, what technologies that we currently consider surrealistic or even just possibly achievable in the future could revolutionize technological progress and solve key global problems of humanity? What are your thoughts? What are some technologies that today are just sort of on the verge of existing, but could really change the way that we solve problems in the future?
I will go for that. From the in order to talk about it from data scientist view, I can say that after the introduction of 5G, and as you see, IoT is kind of conquering people's life. Now we see so many smart homes, smart workplaces over there, and the first thing that has to come to our mind is to be surrounded by massive amount of data. Billions of data points are getting created each day, and when you think of 10 years from now on, I think I don't know. I think we will be overwhelmed by the data sets created, and I think that has two. I think that has two. I can say one negative point and one positive point.
Mm-hmm.
First of all, we have to be conscious about our privacy, our security, because for sure, from each tap on the Instagram to whatever is used as for your smart home, you're in a way sharing some data with the platforms online. And yeah, it's kind of threatening, but in parallel to that, we have so many cybersecurity people who are working on the security of your data set. And as for the positive point, as I said, because of the introduction of 5G and so on, we will be provided with so much more data set. If you go, there are so many articles that are going online and released in the recent years related to data mining of IoT data points. It is really important because most of the data points which are gathered from IoT are so much unstructured. Working with them is really hard, but you will have so many information. And I think a person who is able to find associations hidden in such data points will, I think, lead the world. And also, as my field of interest is NLP as well, from 2018, you see a revolution in NLP. It is a little bit slower than computer vision, but after introduction of BERT, the stillbirth, the transformers, attention-based transformer, I think we have to expect a super fantastic, bright future for NLP, and I'm pretty sure that it will come up with cool results in maybe 2 or 3 years from now on. These are the two things that I think we will be able to apply in our lives in the future more and more in a better way.
Very nice. I mean, I totally agree there, right? Natural language processing traditionally has moved, slower than other fields like computer vision, but I feel like that's changing, especially with BERT. Like I've seen research projects that have been going on at certain companies for like 5, 6 years, and right as like they'd been going for like 3.5, 4 years, and right as BERT was released, they literally pivoted all of their research to now work on top of BERT, and so
Exactly.
it's been incredibly revolutionary in how we deal with natural language processing. So yeah, it's definitely interesting to see. But yes, Soumya, what do you think? Some technologies that today we consider surreal, or things that we're not sure if they're possible, but could end up changing the way that we live in the future.
Yeah, absolutely. So I actually recently read Hit Refresh by Microsoft CEO Satya Nadella, and it was interesting to like see his view and like on technology and what are going to be the disruptors in the future. And I definitely saw a lot of focus on like quantum computing
Mm-hmm.
um, and quantum computing and like machine learning AI is definitely the future. And he definitely talked about how they are going to revolutionize like technology um, and this is just not for the next like 5 or 10 years. This is like 20 to 30 years in advance that they're planning. And um, definitely these are like if these are areas of interest to you, I definitely think like if you want to get deeper and deeper into these fields, definitely I feel like you would need an advanced PhD or master's degree to like get to that point because that's how it's been going on. And um yeah, and I think like all these fields are so broad that like you definitely need an expert view, similarly to how like doctors and lawyers need their degrees to really like vouch for their credibility. I think that you would need advanced degrees to really like go into deep into them, other than just like talking um, about them.
That makes total sense. So I feel like maybe the overarching theme, with both of you here has been sort of, I mean, first of all, actually, before you even get to that, quantum computing is definitely something that really interesting because,
Mm.
it's a technology that is in its infancy, similar to how today's classical computers were a couple decades ago, and seeing the sort of progress that people have made. IBM, I believe, now has a quantum computer with quantum volume, I think 32, if I'm not mistaken, which quantum volume is their measure of not just how many qubits they have, but also the error of those qubits and how they interconnect. which I think is much more of a meaningful measure than just, hey, we have 1,000 qubits, but we can't really do anything with them. And so, it's going to be interesting to see what we can do. It's going to require a lot of like reinvention and sort of rethinking fundamentally what algorithms and what tasks we run on those processors. Obviously, we're not going to run everything on them, right? I mean, running an addition is going to fundamentally be slower on a quantum computer than it is on a classical computer because everything needs to be reversible. But still, it's an interesting field, and I can't wait to see what we do with it. Especially in physics, it'll be interesting. But okay, there is another question here from a YouTube channel, Astronomy with Manas. He's joining us today, and he's saying, "I'm 13 and I'm learning Python. Will learning programming help me in my career in astronomy and physics?" One thing I will say beforehand is what I believe is that, when you learn technology, of course, we mentioned how it's important to learn sort of what goes behind technology and sort of the field that you want to apply it in. But learning about technology can also help you learn more about individual fields, I think, just because of the fact that fundamentally you can do more in that field if you can create the technology that you want to use, right? If you have a lot of astronomy data, which itself obviously requires, lots of big data, and if you know how to write the computer programs to actually process that data yourself, and work with it, you suddenly have so much more flexibility compared to someone who has to work with the tools that already kind of exist for them. So first of all, I do think it will help, but Soumya, Malikeh, what other kinds of thoughts do you have?
I agree. I think, first of all, knowing programming language is one of the essential skills nowadays, and I think it's one of the things that any person living in the current world should know. As for physics and astronomy, I don't know. First of all, I can start with machine learning. If you know programming, and if you are pretty sure that from in some stage in your life you'll be able to collect some data points related to that, something that human cannot do, but you need some processing of the, I don't know, pictures from the sky, I don't know, whatever. It can be used. It can be used. Believe me, in any industry, I think employers should employ a machine learning engineer in any industry, I think, these days. I'm pretty sure that in the future, if this person become expert, we'll be able to provide some data points to be used in machine learning itself. Or for example, if you're good at, I don't know, developing apps, developing websites, for sure, you can become a good instructor of physics, and you can build your own web page, your own application, and with your own language, your own mindset, you will transfer that to the people whom you are working with. I cannot say it can be directly used in any problem you're working on in physics. And also, Python and MATLAB are really good to work with mathematics. And in the future, if you're going to work on astronomy and physics, also math, any theoretical things which are based on super complicated calculations, these kinds of platforms will help you a lot, specifically, as I said, MATLAB, R, and Python in probabilistics and also mathematics in your calculations. It can be used for sure. You cannot do all the things by your hand, and you can enhance your the speed of your learning, the speed of your calculations, and you can focus on the topic and leave the rest to your laptop, to your computer to do. I think in these three areas, they come to my mind now. For sure, there are so many other applications, but I think it can be helpful.
Wow. Thank you for sharing, man. I gotta say, if I may recommend really quickly, you mentioned MATLAB. If I may sort of interject there and say a free and open source alternative, Julia. So do take a look at Julia as well. Julia's team actually has worked with NASA, and they do generally have a pretty large focus on the field of astronomy to begin with, and physics, as well as really other sort of scientific computing areas. So do take a look at Julia. It's kind of like if you were to get the best of MATLAB, C, and Python. It's dynamically typed like Python, so it reads like Python. But because it compiles just in time with LLVM, it runs like C, is the idea. And of course, it has packages that let it act like MATLAB and has all these sorts of fun tools that you can use. So do take a look at that. In fact, I do have a book on the Julia programming language, which was the first in the Tanmay Teacher series with McGraw-Hill. So do take a look at that as well. I'll link to that in the description. So now, I mean, we are getting, pretty deep into today's episode. I mean, thank you very much for asking so many questions, everybody. There is one more that I want to end on today, though. A bit more of a fun question from BQ. He's asking, what does the work, life, and school balance look like for us? So is there a certain schedule or a ratio of time that you stick to? I mean, what about you? What about the two of you? Start off with Soumya, maybe?
Sure. I feel like I keep saying absolutely. So, exactly. So, when it comes to my view of like, I'll speak about like going to the office and working from home scenario. So when you go to the office or like when you go to school, you have that physical like demarcation of like end of things, right? So when a lecture ends, you physically get up and you leave the building. So like to your brain, that signals that, hey, like this is over. Now I take a break or I do something else. And contrasting that with the work from home, study from home, live from home situation, it's like everything is from home, right? So like you're working out from home, you're working on school at home, you're also like networking, or you're also like taking lectures or like workshops like from home. And it's definitely challenging, but I feel like the way I find my way around it is definitely like switching up your location. So like make a room for where you like sit and just do like head down work, but then when it comes to your breaks, like get up from your seat and like move around or like go for a walk or like work out. Like I think that's how I like sort of deal with it. I think working out and like meditating have been like the magical powers or like the magical ingredients to like staying sane throughout all of this. Because then I feel like someone said it best, and it's like um you're not working from home, you're like you're living at work. And I feel like that was such an interesting point that someone made. And like I've sort of like tried to keep that boundary where like I don't let anyone come into my room and like make this like a social hangout. Like I have to get out and have my social meetings or like meeting people. So yeah,
That's an
that's my opinion.
interesting way of looking at it, especially due to the pandemic and stuff. You kind of have to switch up the way you work, switch up the way you structure the time that you spend, how you meet with people and things. So yeah, that's a nice way of doing it. What about you, Malikeh? What does your day-to-day schedule look like? Especially how's it changed maybe during the pandemic?
Yeah, I think it has both pros and cons, and I think sometimes we miss. It is a human nature. We miss something that we do not have. When I was in undergrad, I was overwhelmed with the pressure of the classes, with the pressure of the project courses. It took me hours to go to the university, come back home. Most of my time was used for commuting and go to the classes, and I did not have enough time for myself, for my health, for my sleep, for whatever I need. But for sure, I miss the community, I miss my friends, I miss communicating with the others. But as this is the situation, and we cannot guarantee when will it end. We have to get used to it, and we have to use it in the best way, because we have plenty of more free time for ourselves. And in that way, the most important key point in the pandemic is time management, I think, because you do not have a sense of going to work, coming back to home. It's my free time. It's I don't know, because everything is just the same. You just sit down on your chair, you talk with your friends, you attend the class, you work. You are just the same. So you have to manage yourself, your soul, your mind, your time, all of them are really important. Try to do that by yourself. Pretend that you are living a life like past. Write down a to-do list for yourself. That's the thing that I do. I write down a to-do list every day. I have a Google Calendar. I write down, okay, these days I want to do yoga, or for example, in these days I want to attend some online classes. And some in the weekend I will call my friend, whatever. And in this way, try to kind of break your days into different sections and give a special meaning to them. With giving timing, you will pretend in a way that you're living a life like the past. That's the only thing that I can tell to you. It's a sad story. It's a tragedy, I think, that we are living such a life, but we have to get used to it. And I think at the end of this much free time which is given to us, we have to tell to our friends how many books we read, how many things we did for ourselves, how much we lost weight. Don't get confused and don't get kind of I don't know, lost in this world. Try to use it in your best way.
I absolutely agree, right? Being able to find the positive side of any situation is really important, and especially something like this, right, where we don't really have any option, right? We kind of have to find, the best in what we have, and I guess, the best in this case is the fact that we just have a lot more free time now. We can do a lot more things that maybe we didn't have the time to do before, and there will be some things that are, of course, bad. Like, I mean, apart from the fact, of course, there's an entire pandemic. Apart from that fact, not being able to work in person in some cases can cause a lot of inefficiencies and things. Personally have a couple projects that unfortunately have to be put on hold because it's just fundamentally a lot easier to work on them when you can see the person you're working with, right? And you can both work on a whiteboard or code at the same time physically, right? There's some things that you can't really replace. But fundamentally, I do think that, finding the best in this situation, being able to, adapt and do more or do different things can be, the best way to make the most of the situation. So, this has been a really fun episode. There are, maybe a couple more questions on the live stream that we didn't get to. There are a couple more that I think would be more relevant to ask in next week's episode, but I'll get to that in just a moment. Before that, I do want to say, thank you very much to you, Soumya and Malikeh, for joining today. It's really been a pleasure hearing your thoughts. And before we end, though, I do want to ask the two of you for maybe just a closing message that you want to share with the audience, something that you want to let them know before you go today. Maybe this time we start with Malikeh.
Sure. First, I have to thank you, Tammy, for your invitation. It was my pleasure to have this chat with you and Soumya. I learned a lot today, and I'm really glad that I could share my experiences with you. The only thing that I can tell you was my own experience in my life. Do not limit yourself to the comments of the others. Nobody knows you like yourself. Do not follow the trends. If the trend is computer science, you are not forced to do it. If you like history and if you are talent in this area, I'm sure you will change the world by your historical mindset, maybe. And I think that's the thing that always affected my life. I'm not here because of trend. I'm here because of my passion about math, my passion about engineering. Uh, Choose your future based on your the image that you have built of yourself. Try to understand what are your capabilities and try to be honest with yourself and do whatever will make you glad in the next 10 years from now on. Imagine it, and if you are satisfied with the view and image of yourself in that day, go ahead.
Wow. Thank you very much. Imagining yourself 5, 10 years in the future and being able to say, will I be happy with the decision that I make? Not only do I think is that, such a great message, but it also ties in very well to, something else that I'm working on that everyone will be seeing soon, very soon, within the next week or so. So thank you very much for sharing that, Malikeh, and now Soumya as well. I'd love to hear, what you'd like to share with everybody before we end today's episode.
Yes. So first of all, thank you so much, Tanmay, for having me. And I loved my discussion, like Malikeh's like point of view and your point of view on things. Like this was such an enlightening discussion. To end off, I would say, um, don't give up. Like go left, go right, go up, go down, but just don't give up on things. I think as we have like an access to a plethora of resources, it seems like it seems like you don't know enough or you never know enough. And I think that's don't have that opinion. Like just pick something, keep working at it, and don't give up on your on the project. And first of all, don't give up on yourself. And that's the opinion that I think I would like everyone to like keep in mind, because you can't beat the person who doesn't give up.
Wonderful. Don't give up. Be perseverant, and that definitely comes with passion. So thank you very much, Soumya. Thank you very much, Malikeh. It was an honor having you both on the show for the last episode of 2020. And I gotta say that I've also personally learned so much from this discussion. It's been really fun to have. Thank you for sharing these experiences on the show, and for agreeing to come on during the holidays. I mean, right now is the time you should be having fun. But thank you for actually agreeing to be on this weekend. It's again, it's really fun to see the sort of passion that you have for technology, and also to be able to share that passion with everybody else. I think that's really exciting, and I've loved sort of speaking with you because of that. And of course, I would also love to say a huge thank you to everybody joining into the live stream today. Any other questions, feel free to put them in the comments of the replay once it's on YouTube, and I will go ahead and get Soumya and Malikeh to answer as many of those as we can post the live stream in case we missed anything. And next week, of course, we are continuing Tech Life Skills as normal, Sunday, 11 a.m. Eastern Time, with an Ask Tanmay episode, which should be really fun. You'll get to ask me the questions that you have. More details will be announced later this week. And so thank you very much, everyone, for joining in today. I really do appreciate it. This was a really fun discussion, and I will see you next week. So thank you very much, everyone, and goodbye.
Bye.